Welcome back to the Q-volution, guys. In this second episode, we're gonna go hands-on, from Terraform to Docker all the way into testing, and you'll see how QA builds the entire pipeline from scratch. From testing to owning, QA takes full control, so let's go. Last time we buried traditional QA together with the slow feedback loops late in the game. Now in episode 2, we are gonna take full control of that pipeline, guys. We'll spin up the infrastructure, deploy the containers, and trigger the tests automatically. And in episode 3, we'll push this even further, turning what we've built today into an even smarter testing ecosystem. Alright, let's take a look at what we're about to build. We are creating a fully dynamic test environment from scratch. No more static setups or waiting on DevOps. First, Terraform will spin up our brand new EC2 instance in AWS, our own clean disposable playground, aka our dynamic test environment. Terraform doesn't just create the machine, it can also install the tools we need, like Docker and Docker Compose, preparing the machine for actual usage. After that, Docker Compose will launch our application stack and database inside this freshly created machine. And finally, we'll run our automated rest assured test directly against it. Everything deployed, tested and cleaned up in one flow. By the end of this video, QA won't just run tests, we are taking full control of the entire pipeline. So, now the concept is clear, let's see how each piece actually works before we all connect it in Jenkins. So what you see here is our Terraform setup. It defines an EC2 instance on AWS. This is gonna serve as our dynamic test environment. We use infrastructure as code so anyone can see what is happening and create the same setup every time. And this creates insights in infrastructure. Inside the user data block, we're installing Docker and Docker Compose. Terraform gives us the possibility to also install the tools we need on the machine as it's being created. We add this to the user data so the instance installs everything it needs and is ready to test right away. And the great thing about this is, guys, once the tools are installed, we can directly start testing. And finally, we output the public IP. We'll need this IP later in the pipeline because our tests will run against that address. Without the IP output, we wouldn't be able to connect to the dynamic test environment. This is where QA finally provisions real infrastructure, not waiting on anyone, just spinning it up directly. Now let's apply it. Terraform is creating our EC2 instance, or better said, our dynamic test environment. As you see, once Terraform finishes, it shows the public IP. Let's just grab that address and connect to the machine so you can see how it all works. In the pipeline, we'll need to do something similar, using the IP to copy files from the repository onto the machine before running the tests. Let's close the connection and head over to AWS. As you see, there it is, the EC2 instance Terraform created, exactly as we defined. On the left, you can see the Terraform output from the terminal, and on the right, the same instance in the AWS console. The IPs match, Terraform did exactly what was asked. Now let's destroy the environment. Since this was only a temporary test setup, we don't need to keep it running. This is the whole point of creating dynamic test environments. Spin them up when needed and remove them when the job is done. Now let's look at Docker Compose separately. In the pipeline, this will run automatically after Terraform, but for now I'll show it manually. Everything's defined in one YAML file. Using Docker Compose here lets us describe the application and all its dependencies in code. That means we can spin up the same setup locally as on the EC2 instance or in the CI without changing a thing. Complete consistency from laptop to cloud. Let's take a deeper look at that YAML file. A Python app that represents our application and a Postgres database. Docker Compose pulls the database image, builds the app and brings the whole stack to life. With the Docker Compose stack up and running, we can now run our tests against it. Let's navigate to the rest assured project and trigger the test manually. In the pipeline, this will happen automatically right after startup. We keep the build and test steps separate, so it's easy to spot where things go wrong. If something breaks, we instantly know whether it's the application setup or the tests. And as a bonus, the pipeline stays clean. Each stage does exactly what it's meant to do. Now we run the tests using Docker Run on the same network. Everything passes, confirming that our application is up and running exactly as expected. For now, I'll navigate back to the app folder and close down Docker with Docker Compose down. So far, we've walked through everything separately. Terraform creating the environment, Docker Compose spinning up the application, and rest assured running the tests. But the whole point of this video is to bring it all together in a single automated flow. In the next part, we'll connect these steps inside the Jenkins pipeline so the environment, the application and the tests all run automatically from start to finish. So let's take a look at the first stage. As shown before, we apply the Terraform configuration and capture the output. But this time we're storing it in a variable called app IP. We're going to use that output from the variable in the next stage. In the second stage, we copy a few files from the repository onto the dynamic test environment and then start the application. We use the app IP variable from the previous stage to tell Jenkins where to run these commands, making sure everything happens on the newly created test environment. So once the files are copied over, Jenkins starts the application on that same environment. You might wonder, why do we need to copy all these files? The reason why we copy these files is because each environment is temporary. Every run starts from scratch, so we need to pull in all that's needed: the compose file, the test scripts and the configs. In the test stage, Jenkins runs our integration tests with Docker Run on the same network but separate from the app stack. That way the pipeline stays clean and we can quickly see if something went wrong. And finally, once everything's green, the fourth stage in Jenkins uses Terraform to destroy the environment. We destroy the environment because it served its purpose, and by destroying it, we will also save costs. And ladies and gentlemen, there you have it. QA in control of every step along the way in that pipeline. So to summarize, QA is now in full control, from spinning up the environment with Terraform to deploying the application with Docker Compose and running the tests with rest assured. And once the test succeeded, the temporary environment is destroyed with Terraform as well. This is what modern QA looks like, full in control of the entire lifecycle. And the best thing, guys, now imagine this same process running inside a merge request. Every time code changes, a fresh environment spins up, the tests run immediately and feedback comes early. That's how QA can truly shift left. Awesome, everything works, right? Let's be honest, everything's far from perfect and it can be done in such a much nicer way too. Let's take a look at some bad practices we'll need to fix in the next episode. Terraform marks the environment as ready before the tools are actually installed or healthy. And then the tests start before Docker is actually ready, which will obviously cause failures. To fix the previously mentioned problem, we used hard-coded sleeps in the Jenkins pipeline. This makes the pipeline very unreliable, because sometimes it's way too long and sometimes it doesn't wait enough. We need a proper health check to fix this problem. And the third point is, we built the application inside the same environment that we're testing. That mixes the setup and the validation. And these things should definitely be separated. And the fourth point, our tests are running separately from Terraform at this moment. So infrastructure and validation are out of sync. Terraform finishes first and then the tests run blindly without knowing the environment state. So we'll fix this by adding Ansible to the mix, which I will explain in the next video. QA took back full control. Now it's time to perfect the system. In the next episode, we'll take a deep dive into Terraform and Docker Compose and we'll add a fresh ingredient to the mix called Ansible. For now, thank you for watching, guys. I hope you liked the video and let me know below what you think of this video. See you next time.